Hi everyone. It's a pleasure being here. I'm Gabriele. I'm the author of Pandas AI. I try to use a different approach. So rather than trying to create something generic with AI, I decided to narrow down the potential use cases to only doing data analysis and talking with data, also for not necessarily technical people. That was the idea behind Pandas AI. And to do this, actually, I decided to use a different approach. So instead of trying with agents or chain of thoughts, which are great for a very huge amount of use cases, in this case, what I wanted to do was to maximize the output within the minimum time, so that we didn't have to spend too much time in inference and chaining different prompts and waiting until the very end, but only with one prompt having already the solution. Here's a little bit how it works. So Pandas AI basically has the goal to make data conversational, so democratizing the access to data analytics. And the reason is because data is not accessible to anyone. I mean, of course, there are data analysts, there are data scientists, but most of the times, the people that need to take decisions that are decision-driven, data-driven, are not able to actually ask questions to the data itself. So a huge feedback loop starts. And also, even for the ones that are technical, it comes with a lot of boilerplate. Like to clean up a data set, you need to do a lot of boilerplate code, and the same is, for example, when you want to visualize data, for example, or doing feature engineering, data augmentation, and stuff like that. And this is where Pandas AI can help people in the data analysis space, basically. How it works, basically, it's a step-by-step process where basically Pandas AI gets the metadata from one or several data frame, and then passes the metadata together with some samples of the records within the data frame that are synthesized. So it doesn't really pass real and sensitive data, but it kind of redux some of the data, for example, emails, phone numbers, credit cards, and stuff like that, and shuffle all the rest so that they are, for example, one name is assigned to another surname, and so at the end, it doesn't really make sense because it doesn't. It's not a reference to a specific person. However, there's also a possibility to pass a flag, enforce privacy, that also completely removes these samples. On the other hand, it comes with a slightly worse performance because the large language model needs to get access to as much context as possible to then provide the best output possible. And now, what happens next? Next, the large language model generates the Python code that then is cleaned up a little bit with we have a parsing system that basically parses the whole code and removes some of the most well-known hallucinations. For example, one of the easiest one is that sometimes the data frame, like the large language model, creates a new data frame that overrides the one that you originally passed, and for almost no reason, but it hallucinates and it does that. And so the answer is not correct. So what we do during this parsing phase is basically removing this kind of hallucinations and having a code that also is that doesn't come with all the prompt injections potential threats. In fact, one of the things that we do is we whitelist several libraries that are related to data analysis so that we don't allow any kind of potential unsafe library to run within Pandas AI. And at the very end of the process, it executes the code. And if the code, for any reason, fails, at the end, it launches another call to the large language model trying to fix the code for at least three retries, and then at the end you get the output of the code. This can be either a number or another data frame or a chart, and so that's a little bit how it works under the hood. Now moving on, here are some of the examples. Sorry for the presentation. It's one of the worst you have ever seen in your life, but it's not what I'm good at, and probably next time it will be GPT generated, but yeah, this time I did it. And so basically, some of the questions that you could ask is, for example, how much is the revenue forecast for coming 3 months. So you ask kind of time series analysis, or you can ask to visualize data, or you can ask even questions that are related to different columns within data frame, or you can ask other more incomprehensible questions that the large language model tend to be good enough at understanding based on the context that you provide. But we will see some examples later. Now, moving on, what we decided to do was to be a large language model agnostic by design. In fact, we allow any kind of either open source and closed source model to run with Pandas AI. You can also use the inference API by Hugging Face, for example, with Falcon, Starcoder, Alpaca, and similar. However, what I've seen so far is that the most performing ones, in terms of how likely they are to give you the right answer, are definitely GPT 3.5, which is a good enough. So I would recommend that. That's recommended one. And the other one, which is even better, but I think it's overpowered for this use case, is GPT-4. But as I said, GPT 3.5 is already a very, very good compromise to run with the Pandas AI. Of course, this is the beginning, but many of the open source models are catching up quite fast, and I think in the future you won't rely necessarily on OpenAI. So moving on, this is the architecture of the future that we have in mind. Basically, the user prompts something, then we have a semantic cache layer that is done through vector DBs and similar techniques, so that if a query like that has already been asked, we don't go to the large language model again. And then we orchestrate with several small agents, which in our case are more of a combination of actual code and a prompt, and potentially a large language model with a dedicated adapter for each specific use case. Then it orchestrates, each agent reports back to the orchestrator that then provides the response. This is more of the architecture for the future. And at the very moment, it's just one large language model, so it's quite naive as a solution what we provide at the very moment. And yeah, that's it. There's also the Easter egg for the ones that are more aware of how transformers work, but yeah, that's a little bit it. Now, I want to make it. I wanted to make the presentation as straightforward as possible, because I think that the real value is showing how it works. I think it's more interesting also how it works in a real world scenario, and so that's what I will try to do at the moment. So yeah, I will share a notebook in a second, and well, here it is. Can you see it? I guess
not yet.
Okay.
Oh, it is.
Let me know. Okay, awesome. Okay, yeah. So here's the notebook. I have prepared a couple of examples because I felt that is more interactive and dynamic. If you want to, you can also maybe write something in the chat if you want to have some real-time questions, so that we can make it even more dynamic. But I will start with a more generic introduction, and then maybe we can also ask more in-depth questions, so that we can break it live, which is always quite embarrassing. But yeah, basically, the first thing you have to do is, of course.
Gabriele, do you mind making the screen a little larger, just the font size, Control+?
Totally, yeah, I can definitely do that. Can you see it better now, or
maybe a
even
couple more?
Like this? Is this okay?
Or it's
still too? Let's do it.
Beautiful.
Awesome. Yeah. All right. So basically, as you can see, what you need to install now, I'm installing all these libraries because I have to override basically what Colab, because Colab has already some version installed of some of these plugins, so I want to override them. But basically, the only thing you have to install after all is Pandas AI and Pandas eventually. And so basically, what we do is that we import the libraries, as you can see. And then we declare, so we will import the libraries, then we will declare a data frame. Of course, this is a very easy and naive data frame, but you can also, for example, read from CSV or from Excel, and soon it's going to be coming also the support for Google Sheets. But in this very easy data frame, basically what you have is a country, the GDP for each of the countries, and then a happiness index for each of the countries. This is a fake data frame. The data are not super correct, I think. So don't worry about that. It's just very casual numbers. But yeah, then what you have to do at this point is basically you can instantiate any of the large language models. In this very case, for example, we can instantiate OpenAI, and you can pass the OpenAI API key, and then you instantiate it like this. But as an alternative, you can do exactly the same with Falcon, with Starcoder, or similar. So you can basically use whatever large language model you want between the ones that are supported, or you can also create a wrapper yourself and use your personal large language model. So after that, basically what we do is we instantiate Pandas AI, and we pass the LLM that we have just instantiated. So in this case, OpenAI. And then we can either set conversational true or false. I will explain in a second how it works. And then we can, at the end, run a prompt. In this case, we pass the data frame, which is the one that we have instantiated, we have declared here. And then what we do is we pass a prompt. In this case, we ask, what are the 5 happiest countries? And as you can see, it will answer with a data frame in this very case. And so in this case, as you can see, it's the United States, Canada, Australia, United Kingdom, and Germany. This is fake data again, so don't take it too seriously, but yeah, that's a little bit how it works. So what you can do, and the cool thing is that it is integrated in the Pandas experience. So if you do Pandas, if you use Pandas in your daily activities, you can do, for example, new DF, and basically you declare a new data frame and you execute this, and then you can, for example, run some Pandas things. For example, let's pretend we only want the first 3 records of these outputs. So we do this, and instead of getting the full 5 results, we only get 3. So for example, if I do print the new DF, and then I print this one, you will see that this is the output of the Pandas AI query. But then you can also apply any kind of Pandas transformation, and so basically you can integrate in your workflow. Now, another thing is that it uses cache. So basically, the first time you run a specific query, it can take a little bit longer, of course, because it has to do the inference. But after that, using cache, you don't have to, rerun and wait again. So if you run again, it will be almost instantaneous, as you can see. And also, we have another opportunity. For example, if you want to add in a sort of a chat context, for example, you can pass the conversational true param, and as you can see in this very case, it will make it a little bit more conversational. In this case, to make it conversational, it will basically run an additional inference call to OpenAI, and it will get it a natural language response. So in this case, it's going to be the top 5 happiest countries are United States, Canada, Australia, United Kingdom, and Germany. So it's more conversational if you need, as I said, for example, in a chat context. But let's switch it back to false, and here it is. Now, another super interesting thing is that you can do data visualization, for example. And in this case, for example, we ask to plot a histogram of countries showing for each one the GDP using different colors for each bar. And this is not needed. So we run this, and ideally it should generate a chart. Okay, so we have a very ugly chart generated with matplotlib. But for example, you can also say, let's use, instead of matplotlib, let's use Seaborn as a library, and it should do the same, but with Seaborn, which is a little bit more pleasant to see. So you can also, change the library that it uses. And hopefully it should also show plotlib, but I think it will open on a, not plotly, sorry, but I think it will open in a new window, and chances are okay, here it is. So as you can see, you can pass whatever library you prefer, and it will generate something like this. Another cool thing is that, for example, if you want, you can see, you can run then Pandas AI last executed code, and you will also see how it got to this visualization or to this answer. And so basically, it's gonna, okay, wrong example. I don't know why. This is quite cool, actually, but Yeah, I will show you here, for example. So if you pass it here and you run last executed code, it should, in theory, at this point. Oh yeah, it's last code executed. Sorry, executed. Okay. Yeah. For some reason, I kind of I've broken everything, but okay, let's try again. Okay, so it's last code executed. Sorry about that. So basically, it will show you how it got to answer to this question. And for example, we can do new df, and we print the new df, and then we also print how it got here. So basically, if we run it again, we will see again the new data frame, which is this one, and then the code that it uses to get to this point. Then, for example, here in this context, you can say, instead of using an histogram, you can say, let's do a pie chart of the top 5 countries by GDP. So you can also add, more complex queries, and you can definitely ask for different, a different type of chart to be shown, as I will show you also at a later point. Another super interesting thing is actually that you can interact with not only one data frame, but also multiple data frames. In this very example, you have 2 different data frames. One is for the employees, which contain information like employee ID, name, and department for each employee. And one, you have the salary for each employee. So in one data frame, you don't have all the information that you need, for example, to figure out who is the employee that is paid the most, okay? And so you will have to pass both as a context, and then it will be the large language model that will orchestrate, trying to figure out which data is relevant to then address this query, and then you will get the employee that is paid the most, as we will see, which is Olivia. And if we double check, for example, you see that John, Emma, and Liam, but Olivia, which is number 4, is the one that gets 7K, which is the higher salary in here. And of course, also here, for example, you can see how we got to this answer. But one of the interesting things is that, for example, you can ask, what's the average salary in the IT department? And again, it should answer, 4,500. Now, if you change, for example, also to have another IT department here, and you run again, the average will definitely change, because of course it has to do the average between these 2 numbers. And that's a little bit how it works on a query perspective. So you can do every kind of a natural language query, and it will provide you either a chart or an answer or a data frame that you can then use for other transformations. But there are other things that you can do, for example, which we are calling shortcuts. Now, shortcuts are a way to not having even to pass any kind of prompt, because it's already implicit in the function that you use. For example, if you do clean data, it will automatically perform data cleaning prompt, so you don't have to pass anything in particular, apart, of course, to the data frame or multiple data frames. The same you can do, for example, for input missing values, generate features, and also if you want to plot pie chart. So it's already here. You just need to pass the labels and the values that you want to use to generate this chart. And the same for the histogram. And I mean, the whole list can be found in the documentation, but there are quite a few interesting things that you can do. For example, in here, also the correlation heat map. In this case, it's quite useless, but yeah, that's another story. And also, for example, if you do some finance, you have functions like the rolling average and similar things. This is just so that you don't have to do all the time the prompt over, because you already have it under the hood. And another interesting thing, for example, you can do a customer segmentation. And in this case, for example, you have these customers, and let's say you have them, their age, their income, their gender, their country, and stuff like that. And let's pretend we want to create segments of the customers by 2 features, which are age and income. And we want to generate ideally 5 clusters for this. And this is I will comment this out for now. And for example, if you run this, okay, now it's complaining about missing site. Okay, interesting. All right, that's the beautiful thing of the demo. It never works as intended. I think in this very case, I need to install a package, and that is mandatory. And I haven't installed at the very beginning. But basically what it does is, ideally, if everything is set up correctly, we can also give it a shot. Pip install, let's try. Okay, that's like this. And let's see. Maybe it will work, maybe not, but let's see. And all right, so if we try again, okay, it's still, okay, for some reason it's still missing, but in a real world scenario, it works. I can give it for granted. And also, for example, you can do, oh yeah, you're right, actually. Let's try it like this, but it should be there actually. No, it's, yeah, for some reason there's like some problem with, yeah, there's some problem probably with the Colab setup, but yeah, that's a little bit how it works. And also, if you get a data frame, you can do then other follow-up questions like this, and only return customers, for example, for cluster 2. But this is another example. And finally, if it works, because I think, again, we have a problem with the library, but you can do time series analysis. So for example, you can say, predict the sales for the next 12 months, with scikit-learn, and it should work. Let's see. Hopefully, I would say. So it does also a little bit of time series analysis and forecasting, which is another nice feature to have for a data analyst. And as you can see, it's actually running the code, and it should generate a list of the next, the expected sales for the next 12 periods, which is taking like forever. But as you can see, here it is. So basically, based on this few contexts, of course, in this case, it's very few contexts, but it can, with more context, the output would definitely be more accurate. And this is a little bit it for what we can do. And yeah, there is something more than this that I can probably show, and is that the fact that if you want, for example, you can have a interface for this. So let me go to this. Okay, this is an example of using Streamlit to create a sort of interface to make it more conversational with a UI. So it doesn't need to be a tool only addressed to developers. And I have a couple of very interesting datasets here, which are the Titanic dataset, which contains a little bit of information of the passengers of the Titanic. And you can ask whatever question you want to this kind of CSV, and how many people died, and it will probably, hopefully, give you the answer. Now it's so fast because this question has already been asked, and so it's cached. But if you ask, for example, survived, okay, also this one was cached in total. As you can see, you get the output, so it's counting. And in this case, also you can see the code. So, for example, in this case, it just did the count how many records in the data frame, and then it prints it basically. But you can ask, for example, how many female there were, and it should take some time in this case because it wasn't cached, and you will get the answer, which is 152. And we can also say, for example, filter only by the males, and it should again provide you a data frame that is only filtered by males. So basically, as you can see, the gender are only males in this very case. Or you can do filter by people aged less than 40, and you will again have the answer with only people that are less than 40. And you can also, for example, download the CSV if you need, so that you have it ready for your further analysis. But also you can, for example, plot a chart of gender let's say of amount of passengers by gender, and it will automatically try to also visualize what you asked in a similar way of what we did also in the other kind of demo. And that's a little bit it. Again, you can see the code if you want, and you can also learn from the code if you are not super skilled in Python or Pandas. And that's a little bit it. But the cool thing is that you can also add multiple files. In this case, let's also try to upload the Tesla pricing, like in 2022, and you can ask what has been the highest price in 2022, and it should automatically figure out. And this is interesting. Now, what it does is we are passing not only one data set, but we're passing multiple data sets. And it's the large language model that is orchestrating to figure out which data set is relevant to your question. So it doesn't matter if you also pass the Titanic data set, because it doesn't have any kind of a relevance with this very question. And so you get this, which is, as you can see, the highest amount from the Tesla data frame. And you can ask also question, what was the rolling average on, say, 28th of May 2022? And it should ask the rolling average for Tesla at the very time. So yeah, it's taking forever, but that's a little bit how it works. Yeah, that's it. And you can also ask visualize the price of Tesla, and it should probably plot a chart for that. But yeah, that's a little bit it. So you also plot the chart for, in this case, for Tesla, for the whole period provided. You can also, of course, filter and stuff like that. But yeah, I think this is pretty much it from me. I will be more than happy to answer any questions.